for your attention up here. Today, first day of factoring polynomials. Now, for those of you who are like, well, we've already done factoring. This is factoring polynomials, a bit different than quadratics. It's a little more intense. You use a lot of the same guidelines, but you're going to have degrees that are greater than 2 a lot of times. Okay, so the first part to this to help us kind of get a good place where we can all be on the same page and talk, we're going to do these explorations. So this exploration on page 91 of your student journal, I want you to go ahead and work on that. Please do not use your graphing calculator. Try to do it using logic and reasoning other than that. Okay? Okay, so let's go ahead and take a look at these. The easy one to do is which one? A. It's a quadratic, and we should know that that factors to x minus, or x plus 4 and x plus 1. Meaning I have zeros at -4 and -1. Now, reality is if it's the only quadratic, we could just look at the picture. We didn't even have to do that. We just say, hey, it's this one. But notice it crosses at -1 and -4. Okay, so graph C goes with equation A. All right. Now, how about on, let's try letter C next. How about on C? What could we do? Okay, so it's cubic. Is there anything I could take out of that? X times what is x cubed? X times what's x squared? X times what's -2x? Okay, so now I broke it down to a quadratic. Right, and that's nice once we can get to a quadratic because you can use all those different things we had for quadratics. In this case, we could just factor it. This part we know is going to give us 0. This part gives us x plus 2 and x minus 1. So from here we get -2, and here we get a +1. Those are our solutions. Those are our zeros. When we set this equal to 0, we get -2. We set that equal to 0, we get +1. We set that equal to 0, we get 0. So if we look at our graph, it's a cubic, as Chase said. It's going to have a cubic motion. It's going to cross at -2, 1, and 0. The graph that does that is letter E. -2. Thank you. -2, 1, and 0. Letter E goes with graph C, or equation C. Okay? Let's go ahead and letter E here. Let's come back to that one. All right? Maybe we could try this one. Let's come back to that one. Maybe try this one. Can I take out a greatest common factor? Yes. What is that? Good. So you pull out the x. X times x squared is x cubed, and x times -1 is -x. This part, if we set this, actually I'm going to bring that down. This is difference of 2 squares. Okay, for those of you who are still not recognizing that pattern, it's one that you're going to have to try to learn to memorize, right? If you have a perfect square and a perfect square, if binomial begins with a perfect square, ends with a perfect square, and there's a subtraction sign in between, it brings you to the pattern that you take the square root of the first term, and then the square root of the back term, and then put a plus minus in each. Okay? When you were to multiply that out, the x value, the b term, would end up disappearing. So this gives us 0, -1, and +1 when we set each part equal to 0. And that graph is letter A. Okay, so equation D goes with graph A, -1, 0, 1. All right, so with the 3 remaining graphs, B, D, and C, one is a cubic. Which one's cubic? Like which graph? Graph F is cubic. Okay, notice it also has a y-intercept of, okay, and that's helpful. Crosses right there too. It's only graph, it crosses right. Let me move that. Crosses right there at 2. Okay, it's the only graph that crosses at 2, so graph F goes with equation B. And then when I look at the others, which other equation has a y-intercept? E does. Has a y-intercept of 4. And that y-intercept of 4 helps us out right here with graph D. Equation E goes with D, and by process of elimination, and the y-intercept is 0, 4th degree, that is equation F. All right. How many got them all? Good. Any questions? All right, well, let's try to solve these without having graphs now. So let's take a look at exploration 2. Okay, now exploration number 2, A through F. I want you to, it says use the x-intercepts of the graphs of polynomial functions to write the polynomial in factored form. Okay, kind of ignore these things for a minute. Just do this for me. Write each of them in factored form, and then we're going to solve them. The best you can, and as many as you can. The ones that were a little easier, which one was the easiest one? A, so that's good to hear. That's just basic factoring of x minus 2x plus 1. Correct? Remember the good old days. You're like, oh, that's super swell. That's easy. Okay? Hey, now if we actually solve that, which it's not telling us, but we change the rules up a little bit, this becomes 2 and this becomes negative 1. So that's what x equals. Correct? All right. So those are values of x. Okay. What's the next one that you can solve pretty easy? B. Now, what do we have to do in order to make it so we can solve B? Yeah, other than set it to 0, obviously, but we factor out an x. So when we take out an x, x times what is x cubed? Squared. X times what's x squared? And x times what's negative 2x? Minus 2. And then from there, by doing that, we now have this piece, which we know the answer to that. That's 0. And this piece factors to good, exactly the same thing the first one factored to. So I guess technically that's the factor form. That makes 0. This gives me 2 again, and this gives me negative 1. It's a cubic. It could have up to 3 zeros, or 3 x-intercepts. X would equal negative 1, 2, or negative 1, 0, and 2. And it really doesn't matter your order, but usually we put them numerically. Okay? There we've got it. All right, any questions on those two? So don't forget the greatest common factor. Can we do that on C? Yeah, in fact, we could take the greatest common factor out here. We get an x times x squared minus 2x minus 3. We set all that equal to 0. That gives us x, and this part factors to x minus 3, x plus 1. And so our 3 zeros are 0, 3, and negative 1. Okay, so x equals those things. Oops, 3 first before we, there we got it. Okay, is there anything else we could take the greatest common factor out in those problems? Any of the other problems? Yeah, in E we could take out an x, right? So we set this equal to 0. We could say, okay, x times what's x to the 4th? X cubed. X times what's 2x cubed? Okay, the next term. And minus 2. Now the problem with that is now you have a cubic there, which is not easy to deal with. In this one, can I take out a greatest common factor? No. And we have a 4th power. Not necessarily easy to deal with, at least that you know. And this is a cubic. So the other two methods I'm going to talk to you about today, one you actually know, it just looks a little different. The other one, some of you have seen, because we went through it this summer. Some of you may remember, some of you may not remember at all. Okay, but it's called factor by grouping. When you're doing factor by grouping, if you have more than 2 or 3 terms, you have an even number terms, you're trying to make groups. And so what I'm going to do, just to see if I can do factor by grouping, if you're not good with seeing it right away, what I'm going to do is I'm going to just form 2 groups in this problem. Okay? So in here, I'm just going to insert parentheses. I'm going to make groups. Okay? So I put a set of parentheses there and put a set of parentheses here. Now please note that was just note what I did there. That was just a negative x. And when I put that parenthesis in, what did it become? It became a positive x. So when we do that, we need to include the negative sign with it. But I'm not just putting the parenthesis right here. Otherwise, it looks like I'm multiplying. And I don't want that. So what I'm going to do is I'm going to insert this parenthesis here. I'm going to bring the negative sign in. And this is actually positive. I'm adding those two things. Or if it makes you feel better, then you could just rewrite it as x cubed minus 3x squared in a set of parentheses, and then plus, and then rewrite negative x plus 3. Okay, that may make some of you feel better than doing what you did there. Okay, so I just inserted parentheses. Can I insert them anywhere? You can insert them around whatever you want. Okay, I just put them there because A, you guys really aren't familiar with what to look for, and B, I mean, there's the first two groups. I could have paired the x cubed with the 3 and the 3x squared with the x. It's up to you which groupings you want. Okay?
The sign in front of the 3?
Because it's not minus out here. I made that mistake earlier today. Makes you feel better. Okay, so yeah, you just include that like that. So since the negative's not on the outside. Okay, so what you're doing from here is then with those groups, you're saying, is there a greatest common factor in here? Yes, there is. What is it? X squared. So I'm going to take the x squared out, and just from this first group, x squared times x is x cubed, and x squared times negative 3 is negative 3x squared. So that first grouping became that. Just so we're clear on that, we will use the magical highlighter. Ooh. Ah. Okay. Good? All right. And so, is there a greatest common factor here? Not really, but really what you're trying to do is make the same exact parenthesis set. So I have x minus 3 here, and I have negative x plus 3 here. How can I make this one look like that one? Okay, I can't just randomly multiply by negative 1, because then I have to multiply every term by negative 1. I can factor out a negative 1. If I factor out a negative 1, the negative 1 moves to the outside. And this becomes x. And this becomes negative 3. Notice if I brought the negative 1 back in, it would turn back into that. Okay? So this now became this. Now, so just so we're clear, the whole point of factor by grouping is to get identical groupings at the end. If you do all this and you don't have identical groupings, you just spend a lot of time doing math that didn't help you. I mean, it was fun, but it didn't necessarily help you. Okay? So now I have same groupings. We good? I'm going to make f of x equals 0. So that means this thing right here, which you may not know what to do with yet, which I'm going to try to bring home to you right here. Let's say, for instance, I had 3, trying to make this up as I go here, times y plus 4 times, or actually 4x times, 4xy. Now I wanted to factor something out of that. What can I take out of each? Y. In fact, I'm just going to put the thing in parentheses that I can take out, just to emphasize it. I can take y out. What am I left with? 3 plus 4x. Everyone with me? Okay, and I took what out? Y. Now, let's take what we know here. That's pretty easy. Now let's apply it here. What can I take out? What do they have in common? They have this piece in common. Okay? Now, before you write anything down, they have this piece in common. What are you left with? Here I'd be left with x squared, and here I'd be left with negative 1. That is a parenthesis. Just like in this problem, it was a parenthesis. Okay? And what did we put on the outside? Well, the thing they had in common. That's what you put in the outside. So here we put x minus 3. Now I'm going to put it on the outside on this side because I don't have room over there. But you have now done factor by grouping. You have factored it. You have two quantities that multiply to make 0, which is what you want because now you can solve. You can set each set equal to 0. That means if this thing right here times this thing right here makes 0, then one of these is 0. What makes x minus 3 0? 3. This right here, well, we technically haven't finished factoring. What is this thing called? This is difference of two perfect squares. You have to start recognizing that. That factors to x plus 1, x minus 1, and then technically this will keep bringing down there. So now we've technically factored it completely. We cannot factor any further. Your solution here gives you -1. Your solution here gives you 1, and your solution here gives you 3. So our solution set is x equals plus minus 1 and 3. Notice we're lazy, so we only want to write the number 1 once, so we put plus minus. Okay? It's a lot of work. All right. No. All right. Now I think you got it. Okay? It's factored by grouping. It's pretty cool. Now, here's my deal. Oh, first, any questions there? If I go on to letter E, notice I have a polynomial. I'm ignoring the x here for a minute. Let's just pretend it doesn't exist. A polynomial with 4 terms. Try to group those and do factor by grouping if it'll work. Just ignore the x on the outside. We'll put that back in at the end. I give you a little more. I'm gonna start working through it. You don't have to look. Now, I said I was going to ignore the x, so I'm not going to bring it down there. Okay? Hey, go ahead and you guys can bring it down. I'm just ignoring because I don't want it to be a confusing piece here in a minute. Okay, so out of the first grouping, I'm going to pull out x squared. Out of the second grouping, I'm going to pull out -1. Okay, how many made it that far? All right, I'm left with the common denominator of x, or the common factor of x plus 2, and then I take out x squared, or I have left x squared minus 1. How many made it that far? And now I'm bringing down this x.
Oh, that's what we're supposed to do.
Okay? You guys with me?
Yep.
Okay, and now I'm going to rewrite this whole thing as x times x plus 2 times, what's this? And all that equals 0, our hero. So we get 0, -2, -1, 1. X equals -2, 0, plus minus 1. Okay, how many got it? Isn't that neato?
It's neat a burrito.
Yeah, man. Okay, any questions? All right, notice it's a 4th degree. What's the maximum number of zeros it could have? 4. Now remember, a 3rd degree, what's the max it can have? 3. Could it have any fewer than 3? How many? Could it have 2? Could it have 1? Could it have 0? No, because the end behavior is either down, up, or up, down. One or the other. In this case, down, up. Could this have 0 zeros? Yes, because the end behavior is going the same direction. Doesn't have to hit x. Okay, let's go through this next one. Now, I will tell you this is actually, I think, easier than the previous. Okay, when you're looking at a polynomial and you notice it's an even degree, for instance, on letter F here, we have an even degree. And this even degree happens to have a b term that is half of that. I don't know why that won't focus.
It doesn't like you.
Try it again. Well, that's a little better. Okay. So if I'm focusing in, let's make sure okay, we're looking at this guy right here. Okay. This power is 4, that power is 2. Notice this power up here on letter A, that was 2, this power was 1. If your highest degree, if you have 3 terms and your highest degree is twice that of your middle term, your b term, you can think of it as a quadratic. In fact, we can think of this as x squared, or let's do it this way. We want something to the second power and something to the first power. And then we have our constant on the end. Got it? Just like in this one, we have something to the second power and something to the first power and a constant on the end. You guys seeing the relation? Okay. Something to the second. What is being raised to the second power here? X squared. X squared to the second is x to the 4th. Okay? The question is the same x squared to the first x squared? Can you have or do you have the same things in the parentheses? X squared? X squared?
No, because it's the 10.
Yeah, we got to put the 10 on the outside then. You guys following me? Okay, this is a quadratic. If you're like, that looks way confusing, I would agree. When I do these, I just think of it like this. And I'm not going to use x's just because we're using x's. I just think of it like this. Y squared minus 10y plus 9. How do I factor that? Well, I just think of it as, well, that's y minus 9, y minus 1. Okay? It's just that this thing that we're calling second power and first power is not y here. It's x squared. So if this was actually a y squared in here and a y squared, that would just make that y squared and y squared. So all you really have to do is say, well, that's x minus 9 and x minus 1. And since it's squared, we make those squared. That is so much easier. But mathematically, this is what's happening. That's how it's going to be shown to you in a textbook. Okay? Either that or they're going to write it in function notation and completely change the function and write it like this. But I'm not going to do that. Okay? Now, with that being said, let's go ahead and recognize that this is what? Difference of two perfect squares. And this is difference of two perfect squares. And notice we end up with how many zeros here? We have 4. Positive and negative 3. And positive negative 1. That's so neat, man. Dun 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 dun. All right.
I like the sound effects at the end.
Any questions? Okay, one other pattern I want to point out to you today, just because, and it's given to you. If you take a look at page 93 of your student journal, please note you're given 2 patterns here. One is called the sum of 2 cubes, and the other is difference of 2 cubes. Just like we have difference of 2 squares. Difference of 2 squares, by the way, is this form. A squared minus b squared is, what is it? Come on, if that's difference of 2 squares, how do we write that? You guys have been doing it all day. Okay, good. So that's how this is describing it. This is saying, hey, if you're given two cubes, perfect cubes, and they're adding them, then it breaks down to this factored form. Is that nice to know? Yeah, dude, that's really nice to know because now you don't have to go through all the other process. It's a pattern. Okay, just like when we do difference of two perfect squares, we just break it down. We don't put any other thought into it. It's a pattern. Same thing with difference of two cubes. Now, the part that always got me until I started really thinking through it was, look, when I'm adding, there's somehow a subtraction sign in there. And when I'm subtracting, there's somehow just addition over here. The way I try to remember this, I look at it as, hey, a plus b, or a cubed plus b cubed, I always start with a plus b. I always start with the plus. And in the second set, I have a subtraction sign. Why? Because it's weird. I don't know. It's odd. Okay? Get it? 3 is odd. There's mathematical reasons for it, but we don't have the time to dive into deriving the difference of cubes and stuff. Okay? And then the subtraction starts with a subtraction. And then there's no subtraction in the back. Okay? We with that? So if I'm doing one of these, if you take a look at your student journal, page, let's see, 94. I want you to find in the exercise set there one problem that is difference of two cubes. Or sum of two cubes. I don't care. Number 3? Okay. So if we're using number 3, I want you guys to apply the formula right there. Or apply the pattern there. Okay? All right. Hey guys, so if you're doing this one, this is A, we would be using the pattern on number 3, A plus B, or A cubed, excuse me, plus B cubed. This would be my A cubed. That means if I'm actually applying that, remember that's equal to A minus B, or excuse me, A plus B, times, what's the rest of it? Okay, so in order to do this, first you need to figure out what A and B are. Okay, now it's kind of confusing since they put an A and B there, but when we have A cubed, A is actually the cubed root of A cubed. So what's the cubed root of 27A cubed? 3A. What's the cubed root of this? 2B. Okay, that is this part. Okay, so this is this. You take the cubed root of each of those. All right, to get the back part, we now square what A was, which is 9A squared. We multiply A by B and subtract it. Gives us 3AB times 2B, or 3A times 2B is, and we square B. You've now factored it. Okay? That part is that part. Okay? Questions? Can I do what? Okay. How did I get this? This is A right here, and this is B. So you've got to square A, 9A squared, and you got to multiply A by B, and then you got to square B. Okay, Hallie? It's a quartic. All right. Hey, please turn the page. Take a look at page 95. Last one we're doing. Page 95. While you're doing this one, or we're going to go through this one real quick. It says, show the binomial is a factor of the polynomial, then factor the function completely. All right. With this, I know last week we talked about being able to just plug in -1 and see if it goes into it. Well, one of the benefits of actually using synthetic division to see if it works is if you find out it does work, then you already have what you're multiplying by. So if you follow through with me here, the first part is to see if it's factor. The second part is going to be factor it completely. So what I'm going to do is I'm going to do synthetic division. This is x cubed, and we're adding to it 0x squared. Remember, we want that place value holder, as some of you found out last assignment there. So our coefficients are 1, 0, -13, and -12. So 1, 0, -13, -12, using synthetic division. Now, if x plus 1 is a factor, when I'm done, what should my remainder be? It should be 0. It's whatever makes this 0. Yep. Is it? Good. Now the benefit of using synthetic division is once you go, yeah, it is, now you actually know what you multiplied x plus 1 by. So you are multiplying x plus 1 by this. 1x squared minus x minus 12. Those two things multiplied together make this function right here. You have now factored it. Okay, and the benefit of factoring it, to there is that now you can look at the quadratic and go, can I keep factoring? Yeah, it's x. Okay, and if we were to, it doesn't say to solve, but if we were solving, our solutions would be 4, -3, -1. You can put them in numeric order, but I'm just going to leave it like that for now.